Most of this session is based on chapter 3 of a book called R for Data Science, which is an excellent book, and it's also available freely online. So ggplot or ggplot2, I'll commonly refer to it now as ggplot, is one of several plotting systems in R. It is the most commonly used by far, I think. Why do people use ggplot? Well, yeah. Number one, it's easy to make, well, pretty easy to make good-looking plots straight away. Although you do have to, I've included arguments for why you should, why I should be teaching ggplot first without looking at other systems, or why I shouldn't be. And one of the criticisms is that it's very easy to make medium quality plots, but in order to make high quality plots, you do have to go to some extra work and not rely on the first plot that comes out, even though it might look quite reasonable. Yes, it takes a little bit more work, and you should perhaps refer to the R for Data Science book to give you all the options, because we won't be able to cover all of them now, but we should be able to produce some nice looking plots and show you what's possible. Number two, it meshes well with all the principles we'll be learning. For this session, we'll be using MPG data, which is data on car efficiency for US cars of 38 models that were produced in both 1999 and 2008. So, I don't know, Ford might have come, well, we'll do it for UK examples because I don't know all the US examples, but a Ford Focus might have come out in 1999, but it also existed in 2008, so there'll be two observations of that car. So if you type, I won't explain this right now, there's a later session on what this means, but if you can just type MPG, all in lowercase, and then this arrow here, and then the minus sign, and then MPG. If you've done that correctly, you should have MPG appearing in this environment window here. So we've loaded in this is just loading in the data sets for now. I'll keep it as simple as that. We might want to view the data set. So there are several ways to do this. I'm going to cover two of my preferred methods. Number one is to click on this text, either the MPG or the 234 observations. If you click on that, you will get the data set in a new tab. If you click, this is very useful for when you're using multiple monitors. If you click on this button here, are you okay? That will bring out the data frame in a new window. So that's very useful when you're when you're trying to write code, but you also need to reference the data set. The second option is to either in the console or in the editor. So if you went back to the the editor tab, or just type in the console, we'll use the editor as there. And if you type in MPG, so that's the name of the data frame, MPG, and then run it, Control Enter, you'll get a preview. So how many unique models of car do we have, which is quite a simple question to answer if you know where to look. And number two, I'd like you to perhaps get an understanding of what the variables might be. I mean, we have column headers, but it's not maybe immediately obvious what those column headers might mean. I will fill you in at the end, but perhaps you can have guesses as to what they might mean. Specifically, really asking you to have a guess of what that might mean: DISPL, CTY, and HWY. DISPL is displacement, so that's the engine size of the car. CTY is the miles per gallon in city environments, and HWY is the miles per gallon in on the highway. It's hard to see exactly what's going on just by glancing at a data frame. So a graphic will really help us understand what's going on with this data set, especially all 234 observations. So as John Tukey said, the simple graph has brought more information to the analyst's mind than any other device. And we're going to use some graphics to illuminate, well, this question: do cars with large engines use more fuel than cars with small engines? We can investigate this by typing this command here. And note R is case sensitive, so hopefully all of your coding will be in lowercase. Good practice to put this command on a separate line. So the plus will end the line above. You press enter if you're in the editor. You press enter to get it to the second line. It will automatically indent, but with 2 spaces, and then you'll type the second. And you can edit if you've already done it as 1 line. The editor allows you to just edit the style there. The graphic should be visible in this bottom right-hand panel. Now, what we did, which is quite important to understand this, first of all, we did we typed the command ggplot, and within the brackets we referred to the data set. So we begin our graphic always, if we're using a ggplot graphic, we begin with ggplot and the brackets. Inside the ggplot command will often specify the name of the data. I've done it explicitly here, so we've got data equals mpg. And then we'll add a layer. They're called layers. The John point was a layer. We'll add them with plus, and plus will always go, when you're adding layers, you can add multiple layers. It will always go at the end of a line. So does everyone have a notepad? Because I'm going to ask you to do an exercise here. And the idea is to understand how we move from a data to a graphic. And I've got this example, actually real-life data set that I created. Very simple. I just want you to create a graphic from this data below, and you get a bonus point if you can tell me what this data set is. The point of this exercise was to demonstrate what we're doing in ggplot and the choices we make. And the first one is perhaps what shape will represent the data. So you could have a bar, or you could have a point, and that is the geom. Or when we're typing, we'll refer to different geoms, and that's the geometric object. But the second choice is what visual and inverted in brackets aesthetic attributes do we give to the geom? So what do we do with our point? Once we've decided that we want a point, do we want it large or do we want it small? So size would be an aesthetic decision. Position on the x-axis, position on the y-axis is also an aesthetic attribute. And the color is obviously an aesthetic attribute, the color of the point. So all of those are aesthetic attributes. So here we can see, again, our second line was, we chose a geom, we chose the shape we wanted to represent our data, and then we chose our aesthetics. We have our x and our y, which go in the aesthetic function inside the brackets of aesthetic. But you can also compress that code into shorthand version, because ggplot knows the order of essential arguments like data, and when you're specifying aesthetic, it knows that the x goes first and the y goes second. So instead of writing explicitly data equals mpg, you could just type mpg there, and instead of having x equals displacement, y equals highway, or HWY, you can just type the x1 first, the y1 second. So a little bit more on geoms. We tend to describe plots by the geom that we use. So a bar, I mean, geom point is perhaps not a good example, but geom bar is obviously a bar chart. Geom line is a line graph. You've got box plots or histograms. Instead of adding a layer geom points, you can add those layers. You will need to change some of the commands somewhat. We can add more than one layer to a plot and have more than one geom in a plot. So we just do that by adding a plus at the end of our, we could add a plus at the end of our point line and add another geom, and that will add, for instance, a line between points, if you get your command right. This command, it doesn't make sense because it just joins up all the dots if you were to run it. Using this style, we'll get some duplication. We'd have to type this twice. And we want to avoid that in coding because if we change anything, we'd have to edit it twice rather than once. So to avoid duplication, we pass what was local here. So this was a local argument to the geom point. We can pass it to the global as a global value, and we do that by putting it in the ggplot function up here. So we'll have, after our data, we'll have a comma, and we'll put the aesthetic in the ggplot function, and that will set the aesthetics for both geom point and geom line. And notice that when you're moving the aesthetics to the ggplot command, it comes second after the data. If you were then to put the an aesthetic in a line or a point in a geom point or a geom line command, it would overwrite the global value for that particular geom. So a geom smooth layer will help us identify patterns in our data, and I'd like you to have a go at adding this to our original plot. So as you typed here, you've got MPG, geom points here. If you put a plus on the end and add a geom smooth, we've managed to get this line up. Some points here, which I will get to now, these points in our data are actually pulling up. Yes, so it's true that our unknown is more here, and that's represented with the grey. But what else might affect fuel consumption? Potentially more aerodynamic and lighter than other cars. They've also got bigger engines, so perhaps they're sports cars. And we want to test this hypothesis. So let's map point color to, we've actually got a variable named class. Let's map point color to class to find out whether we can understand this. So in order to do that, let's just talk through. So as I said before, color is an aesthetic attribute of the shape. So arguments within the aesthetic wrapper, within the brackets, describe how the variable is mapped. So let's add color equals class inside our aesthetic wrapper, and this should give us a different color point. we've added another variable, and we've, I think, shown that you probably all saw that those points that we highlighted in red were classed as two-seaters, so likely to be sports cars, and therefore lighter and more aerodynamic than the rest of the cars, and that explains the upwards movement of the line. I must mention, if you wanted to apply the same colour to all the points, then the colour argument would go outside the aesthetics, the aesthetic function. So here we've only got Rx and Ry inside the aesthetic, and then we've got a comma because that's the first part of the John point argument. The first part of the John point function, and the second part is this colour red, and that would colour all the points red, and it wouldn't give you a legend. The way to address an additional variable is with small multiples or facet plots, and we could do this by adding the facet wrap layer. These are quite visually appealing, I think. So if you copy, probably best to copy some. We'll remove the John Smooth. If you copy a couple of lines from your code previously, and then add a plus at the end of the point line, and type facet wrap, you'll need this inside the function. You'll need this tilde here, and then class. So we're going to have a separate plot for each class of car. You can put aesthetic color equals class as well, and that will provide a different color for each class, which actually helps. So we can do histograms. We can do histograms with this command. So again, we're feeding the aesthetic command to the. So that we only require an X for this. We want to see the distribution of the CTY variable, which is the miles per gallon in a city environment. And then we add the John histogram layer here. It would require a few more lines probably to make it look suitable for any publication or anything like that. But we'll just illustrate one thing you can do to address that. We could specify the bin width. So here it's just defaulted to 30 different bins, but we might want to put a bin width of 4 just to, you don't need to provide it within the aesthetic function. This is just similar to the last one. I encourage you to perhaps copy and paste and then change city to manufacturing and histogram to bar. Depending on the size of your plot window here, you might get some overlap text. So we can switch the axis with a command coordinate flip, which just flips the X and Y axis. When you're executing this last function, anything involving John bar without anything inside the function, it's actually doing a count. So we only had to provide one argument here, so we just provided one variable to aesthetic, and it counted the number of occurrences there. But if you provided 2 variables, for instance, this doesn't actually, because of the way the data is ordered, it doesn't actually make too much sense to do it, but without doing some wrangling, which we haven't covered yet, we couldn't sort this out. But if you were to need to plot one variable against another and use bars, you'd need to override the default argument with by specifying the stat equals identity. Box plots are massive benefit of using R is that they're really, really easy to do. Might want to look at the distribution of miles per gallons in each class, and we can do that with 2 short lines of code. a violin plot, equally as simple. I encourage you again to copy the line above and change box plot to violin. That's just another way of showing the distribution. There are really good cheat sheets available. If you go into RStudio and Help and cheat sheets and the data visualization with ggplot2, labels, nice labels, we can do that with another layer called, well, there are a few options to add labels, but I'm using labs, which allows you to specify. So each argument will be a different label. You can just refer to one. You don't need to refer to all of them. But I'm just demonstrating that you can set the title, the subtitle, which will go just below the title. You can change the name of how the variable appears on the y-axis, for example, and you can give it a caption, which will apply by default will appear on the bottom right of the graph. Function ggsave, and by default that will save the most recent plot, and it will save it in your working directory, which will be your project directory, assuming you've gone through the steps that we've outlined before. So what you do is you type ggsave, and then in inverted commas, you'll just name the plot, type a name of the plot, then you have to specify what kind of output you want. So I've chosen .png, which is a high quality output, but you could do JPEG if you want, or PDF. You will notice if you went to the directory and say open the file that you created, it probably save in the dimensions of your plotting window here. Do save that. I'd just suggest a ggplot intro for now, perhaps, as I put on the board. So you go to File and Save As is one option. You can also click Control and S as you would in another program. And I usually, just for safety, specify the name of the file and .r